Yes, this is the first reaction step now under the reduction process. We have already balanced the first reaction step under reduction process. So we can see that from the first step, we first look at the electrons, we balance up electrons, then we move on to the atoms in each species to balance it up. Then this for the first reaction step. The overall first reaction step is this. Then the second reaction step will now be the one for ion 2 ions to ion 3 ions. So don't forget that ion 2 ions increases to ion 3 ions. So what process is that? That is oxidation. That is oxidation. So which means for oxidation now, we are going to have ion 2 ion, then which increases to ion 3 ion. Now, from ion 2 ion to ion 3 ions, the difference in the electrons is 1. So it increases by 1 electrons. So which means we are going to add up the electrons with the species with the greater number of electrons. That's E minus. So which means here doesn't need much to balance up. So this is our equation 2. Let's call this one equation 1. So let's balance it up now from equation 1. To give manganese 2 ion plus 4 moles of water molecules. This is equation 1. Then equation 2 to give 10 plus 1 moles of electron. That's equation 2. So we are going to solve this simultaneously. So here we have two equations now. So we are going to balance it up electronically. That's our target. So which means we have 5 moles of electrons here. We have 1 mole of electron here. So we balance it by multiplying equation 1 by a factor, yes, which is 1, and equation 2 by another factor, which is 5, in order to balance it up with equation 1. Then we now have tetrazole, that's a manganese 7 ion plus 5 moles of electron plus 8 moles of hydrogen ions to give manganese 2 ions plus 4 moles of water. Then for the next one, we have 5 moles of ion 2 ions, because 5 times this we give 5 moles of ion 2 ion, then to give 5 moles of ion 3 ion plus 5 moles of electron. So the number of electrons will cancel out each other in both equations. So which means the overall redox reaction will now be, and let's wait for that overall redox reaction.